Alright, so I think I'm recording. We're looking at skill packet 5, exponential and logarithms, and we are we're going to work through skill 5E day 2, properties of logarithms. We definitely need to make sure that we know these properties of logarithms very well in these homeworks. So you have to commit this to memory. And you have to be good at not only have it memorized, but good at using it as well. So here in the first 9 problems, it's basically a calculator exercise. We don't have, if you look at a scientific calculator, we don't have a log base 3 button. We have a common log button, and we have a natural log button. Let's show you that on the calculator here. I have this common log button, it just says log, and I have a natural log button, and a lot of people have been thinking that that's an IN and it's actually LN. Alright, so of these formulas, the one that we're going to use in these first 9 problems is this change of base formula. This change of base formula allows us to use our calculator to answer this question. Even though we don't have a log base 3 button, we can use that change of base and use either a common log or a natural log, and we take the log of 20 and we divide it by the log of 3, and we'll have an approximation. It wants to 3 decimals. Let's double check on my calculator, make sure that we're set for 3 decimals. Yeah, because I'll let the calculator do the work and do the rounding. So I want the log of 20. Now I need to close that parenthesis so that it understands that this is my numerator, and then divided by the log of 3. Now the calculator is not so picky about closing that parenthesis, but I do out of habit. So in this first one, I'm getting 2.727 is equivalent to log base 3 of 20 to 3 decimals. And we just do the same thing now for all of these. By the change of base formula, this is common logarithm log of 4 divided by the log of 12. So I come in on my calculator, and I have the log of 4, close the parenthesis, divided by the log of 12, and I get that to 3 decimals, this log base 12 of 4 is 0.558. Now, if I wanted to, I could have used natural logarithm as the ratio. I know that I could use the natural log of 4 divided by the natural log of 12, and I'm going to get the same answer. If I have the natural log ln of 4, close the parenthesis, divided by ln of 12, I'll have the same answer. So it doesn't matter whether I use the common log button or the natural log button if I apply this formula correctly. And the one I'm using is this change of base formula. You can see that it's a ratio of the common logs or it's a ratio of the natural logs. So here I have a common log of 100. Now I don't even need a calculator to figure that out. This is 2 because this logarithm is an exponent. The base 10 is implied. 10 to what power is 100? I know that that number is 2. Now I do not know what log the common log of 5 is. So if I have the log of 100, which I know is 2, if I have the log of 100 divided by the log of 5, I get 2.861. And like I say, I could have used the natural log of 100 divided by, now the natural log of 100 is not going to be 2, divided by the natural log of 5. This ratio is still the same, 2.861. So It's the same directions. It's the same idea. It's kind of repeat. You know, the base is positive and not equal to 1, and I can't take the log of 0 or a negative number, so everything looks good. You know, they're not asking me to do anything that's undefined. So to 3 decimals, I'm getting 8.451. Make sure that when I read this off that sometimes I transpose the numbers. You know, sometimes I don't see it right. I write the numbers backwards or in the reverse order accidentally. Alright, so again, I know by the change of base formula that this is log of 350 divided by the log of 6, or I could have used natural logs, doesn't matter. If I have the log of 350 divided, don't forget to close that parentheses, divided by the log of 6. Let's do it if I don't close the parentheses. If I have log of 350 and I don't close the parenthesis and then I say divided by the log of 6, it's not going to be the same number. You know, there's a mistake there, and it's not because of my formula, it's because I entered it in the calculator wrong. So you must be careful. I'm listening to the radio as I'm doing these, and you can't hear the songs, but that's why I'm being quiet. Not since it's so repetitive, I'm listening to the song rather than describe what I'm doing. But what I'm doing is just applying the change of base formula, and hopefully I'm keying it in right. And hopefully I'm copying the answers down right. I got a lot of hopefullys, don't I? All right. Now, here, you got to be careful here. This is a fraction, so I'm taking the log of a fraction divided by the log of 4. See, this argument, this 1/10, and the previous problems, they were whole numbers. They were positive integers. Now I have a positive fraction, so I just have to be careful in how I key it in. I've got the log of 1 divided by 10. I need to close the parenthesis because I'm taking the log of that fraction, getting that answer, and then dividing by the log of 4. And like I say, it's not so sensitive to closing this parenthesis because it just closes it for me. Apparently, out of habit, I usually do it anyway. And I'm getting negative 1.661. It's okay to get a negative answer. Remember, we can't take the log of a negative number. Our sketch of a basic logarithm, if you have a number that's smaller than 1, the graph is below the x-axis. But a number that's bigger than 1, it's above the x-axis. 1/10 is smaller than 1. That's why it gave us a negative value. So, 1/10, I don't know, is real close to the origin. And if you come down, boom, you're down here, some negative distance. So it makes sense that this is negative. Don't be afraid of negative answers. You just can't take the log of 0 or the log of a negative number. It has to be the log of a positive real number. And decimals are fine, just can't be 0 or negative. Where'd my calculator go? There it is. Alright, so I want the log of this decimal number, which is 0.3, divided by the log of 7. And to 3 decimals, this log base 7 of 3/10. I mean, I suppose you could key it in as a fraction, 3 divided by 10, but I'm just going to key it in as a decimal number like it was given. Divided by the log of 7. And I have negative 0.619. And then this is the last one for that group that has the same directions. And again, I can take the log of a fraction, 4/5. Since that's smaller than 1, I know that numerator is going to be a negative number, and this denominator, since 3 is bigger than 1, it's going to be a positive. So I know on my calculator I'm expecting a negative answer. I have the log of 4/5. That number is less than 1, so that's going to be a negative number. See, negative 0.097. And when I divide that by the log of 3, I get negative 0.203. So I'm going to do the rest of the videos that have the same directions and the same block. This was 1 through 9. Hope it helped, and I hope this recorded also. Talk to you later.